Alright guys, so today we're going to talk about section 7.3, radical functions. Let's think back to what a function is. A function passes the vertical line test, so think for every input there is only one output. A radical function is a function that has a variable under a square root sign, a cube root sign, and a rational exponent would be an exponent that is a fraction. Take a minute and write down this definition. Hit pause. So let's take a look at some examples. Alright, these three examples are all radical functions. Notice this first one here is a square root, this one is a cube root, and this one has a rational exponent which is 1/2, which means the square root. So this one would be the square root of 2x minus 1 plus 1 on the outside. So all three of these are examples. Take a moment, hit pause, and copy these three examples down. Alright, the domain of a radical function is all real numbers for which we can take the radical expression. So think of things that you could not take the square root of. That would be negatives under the square root and any even roots. So make note, even, you cannot take a square root, 4th root, 6th root, 18th root of a negative number. So we can't have them in the domain. So let's take a look at identifying domain and range of our examples. Alright, so these three examples here. Take a moment and write down the first example. F of x equals the square root of x plus 3. In order to find the domain of your function, you set the radicand, what's under the square root, greater than or equal to 0. Solve this inequality. So x can be greater than or equal to -3. -3 is the starting point. So the domain would be from -3 to infinity. The range of your function. The smallest thing that the square root can be is 0. So your range for this one, so there's nothing else outside of your square root, your range will be from 0 to infinity. Now let's take a look at example B. This one is a cube root. Is there any restrictions on odd roots? Can you take the odd root, the cube root of -0 and 0 and positive numbers? The answer is you can take the odd root of any number. So for this one, since it's the cube root, the domain is all real numbers. Your range, let's think the cube root of -8 is -2. The cube root of +8 is +2. And all those numbers going in the negative and positive direction will go on for infinity. So this one is also all real numbers. This is the case for the majority of odd radicals, unless there is absolute value or squares going on in our variables. Now let's take a look at part C. What did I say that this 1/2 in the exponent meant? If you said square root, you are correct. So this one rewritten as a square root would be the square root of 2x minus 1 and then a plus 1 on the outside. To find the domain, let's look back at this example here. What did we do? We took the radicand, the value expression underneath the square root, and we set that greater than or equal to 0. Hit pause and take a minute to solve the domain of this h of x function. Take a moment and look and see if your work looks similar to mine here in green. Now let's take a moment to think about the range of this h of x function. The smallest thing the square root can be is 0. However, we have this extra plus 1 here. So if the smallest thing that our square root can be is 0, but we added 1 to it, our range, instead of being from 0 to infinity, it will change to 1 to infinity. Okay, now let's take a look at the graphs of radical functions. On the left here, the square root of x. The smallest thing that x can be is 0. The square root of 0 is 0. And now, instead of just picking numbers 1, 2, and 3, let's pick perfect square numbers. So 1, 4, and 9. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Each of these 4 values, all set pairs here, are all coordinates on the points on our square root of x graph. So 0, 0, 1, 1, 4, 2, 3. The graph of our square root function looks like this. Notice this point right here is the starting point. So our range, our x values, the smallest x value is this one right here. So domain is 0 to infinity. Our range, thinking going from the bottom up, our range starts at 0 and also goes to positive infinity. Now looking at part B, g of x equals the cube root of x. Previously we said cube root, you can take cube roots of negative. We are still going to plug in 0. Cube root of 0 is 0. However, we could plug in -1 and -8. The cube root of -8, what times itself 3 times gives you -8? That would be -2. The cube root of -1 is -1. Any positive numbers? The cube root of +1 is 1, and the cube root of +8 is 2. So let's take a look at this graph. Whoop. 0, 0, 1, 1, all the way over 8, 2. -1, -1, -8, -2. Here is the graph of the cube root of x. Notice the arrows are going in both directions, left and right, so the domain is -infinity, positive infinity, and the range is also -infinity, positive infinity. Let's take a look at the graphs of the transformations of the square root function. So drawn right now is the square root of x. Our second equation, g of x is the square root of x minus 2. That minus 2 on the outside, how would that affect the graph? Would it move up, down, left, or right? If you plugged in the square root of 0 and got 0 and then subtracted 2, your output for the point 0 would be -2. So that first point would be down 2. The square root of 1 is 1. 1 minus 2 is -1. So your point 1, -1. The square root of 4 is 2. 2 minus 2 is 0. Notice how each of these points are moving down 2. h of x, plus 4 on the inside. If we think back to the domain, x plus 4 greater than or equal to 0, the starting point for x is -4. That's interesting. You would think that your graph is moving to the right 4, where in fact your graph is moving to the left 4. So when it's on the inside of the root, you do opposite what you see. So this is left 4. So each of your points go to the left 4. Now let's take a look at what happens when we have negative symbols in front of your square root sign or inside the square root sign. So j of x in orange. If we have the negative square root of x, our domain is not affected. We still plug in 0 and positive numbers in for x. So our domain is not changing. However, all of your outputs, when you plug in 0, you get 0. When you plug in 1, the square root of 1 is 1. However, we're multiplying that by a negative number. So our output for this is -1. So flip upside down here. The square root of 4 is 2 times -1 is -2. And 9 would be -3. So this one would be a reflection across the x-axis. Now let's take a look at the bright green, k of x. That one is the negative on the inside, so our domain is changing from 0 to infinity to actually -infinity to 0. So that is going to be a reflection across the y-axis. So 0 is still our endpoint, but now -1 would be the square root of 1, which is 1. -4 would be the square root of +4, which is 2. And -9 would result in 3. So the graph of k of x would be this. Take a few moments and hit pause and graph this example. After graphing, state the domain and range of this function. Instead of picking points that we are used to picking, for example, 0, 1, and 4, we have to really focus on picking values that would make x plus 2, 0, 1, 4, and 9. So that's why I chose these 4 values here. -2 plus 2 would be 0, -1 plus 2 would be 1, 2 plus 2 is 4, and 7 plus 2 is 9. So I chose those values on purpose. I plugged in those values each in for x in your equation. That's where these numbers are coming from here. I evaluated them and got my 4 outputs here. So notice the graph on the left-hand side here. The domain, we still solve the domain like normal once we did that in the first example earlier on. The range, let's look at our graph to see our range. The smallest y value that we would come across is right here at -5. So the range is from -5 to infinity. So now let's try graphing a cube root. Take a moment and write down this example. Nice cube roots that I always try to do is I want the radicand, the values under the cube root, to be these 5 numbers here on the right. -8, -1, 0, 1, and 8. Hit pause and try to come up with 5 values that would make x minus 1 equal those 5 values I wrote there, and try to graph the cube root of x minus 1 plus 2. Okay, so these are the values that would make x minus 1 these perfect cubes over here. I evaluated all of them. All of these came from our x values minus 1. So those are our 5 perfect cubes. And then all of them needed the plus 2. So all of these 5 values here are the outputs. Graphing this, -7, 0, 0, 1, 1, 2, 2, 3, and 9, 4. Here is the graph of our cube root function. Remember, domain and range for cube roots are all real numbers. Come back and hit pause and rewatch this video to go through the steps of graphing radical functions, specifically square roots and cube roots. Remember that you can always go back to your textbook to look at other examples they have, and I will gladly answer any questions you may have about this section. Thanks, guys.